Good morning, everyone. We are ELECOMP Team Takeo Comfort Solutions, and we are here to present our Capstone Design project, the Voltage to Pulse Width Modulation Converter. We would like to start out by introducing our technical directors and then ourselves. Here, you can see our directors in firmware development, Phil Manning and Nick Costello, and our director in hardware development, Robert Kelliker. Next, you can see this picture of Team Takeo. Paul Crisafulli and I, Christopher Volsi, are both electrical engineers. We handle the hardware and test fixture aspects of the project respectively. Tim Boyd is pictured on the right, who handled the firmware of the device. I would like to take a moment to discuss our sponsoring company for this project. Takeo Comfort Solutions was established in 1920 as the thermal appliance company and has since managed to become a leading ISO 9001 manufacturer of heating and cooling equipment. They are headquartered in Cranston, Rhode Island, but have partnering companies located across the globe, such as Canada and Italy. Their main market is for the development of products and systems for residential and commercial applications, which leads directly into the motivation for this project. Takeo currently manufactures a pump which operates on a digital control scheme known as Pulse Width Modulation, or PWM for short. This is due to the important need for electrical isolation in the pump, in order to meet UL and other international standards. It is also an extremely cheap and simple control method. By changing the time that a square wave is on as opposed to off, one can easily manage the speed of the motor with a simple microprocessor. Most boilers in the United States, however, operate on an analog control scheme, using voltage level to control the speed of the pumps. From this, we see a discrepancy. Of this discrepancy, however, comes a solution. In order to use their digital pump in the analog boiler market, Takeo proposed the design of a low-cost voltage to PWM converter. In order to realize the projected $350,000 to $400,000 profit increase.
To start off the further details of the project, I'd like to begin by reiterating from our fall symposium presentation that our anticipated best outcome has been fully completed. Specifically, this means the following things. We were tasked with designing a two-way voltage to PWM converter, which would include options for both AC and DC power, power on safety diagnostics to ensure the device hardware is working as expected, production line testing capability through Takeo's proprietary, packet-based, CRC-protected protocol, Takeo Bus Lite, with a PCB and fitting an existing Takeo enclosure, which could be ready by the spring for in-lab alpha testing. And by the spring, our goals had expanded to meet the pace and progress we were making. In order to properly implement Takeo Bus Lite, we also decided to make key upgrades to the Takeo Bus GUI. We also decided to carry out and complete the alpha testing for the device, which led to the desire for an upgraded processor architecture and the ability to prepare for and possibly carry out in-field beta testing. This was accompanied with the team making as many changes as possible before releasing our Engineering Build 1 production-ready hardware and firmware. We also took on the creation of a demonstration test fixture for use in analytics and limit testing. And finally, we sought to fully implement near-field communication into our device, which we will discuss in the coming slides. In the fall, the result of our work ended up boiling down to the circuit shown here. But let's take this step by step in order to understand each component of our design. We began by selecting a core processor, which could handle all of the hardware and firmware operations necessary to carry out the conversions from voltage to PWM and vice versa. This was followed by adding hardware to allow both the 12 volts DC and 24 volts AC power signals to power our device. Next, the crucial hardware for converting outside signals into those manageable by the microprocessor was implemented, along with a dedicated communication bus to allow the device to communicate with a computer over USB. With this hardware, the next steps for us were to implement firmware which could transduce and produce the signals necessary for communicating with both the pump and the boiler, as well as implementing firmware which could communicate over the bus to the terminal. Next, we implemented as many of the Class B functions as possible, allowing Takeo to ensure that when each device powers up, its hardware is safe and ready to run. Followed by fully implementing the firmware state machines so the device could receive and transmit Takeo Bus Lite packets to the terminal while storing key values in the flash space of the device.
As we mentioned before, we on Team Takeo were able to meet all of these goals by the fall symposium, so we spent the winter break deciding how to take that momentum from the fall and turn it into even more progress for the spring semester. From this we determined the need for an upgraded processor which could produce cleaner analog output signals and more robustly handle internal memory operations. Doing this meant refactoring all of the firmware to fit this new processor family, but ultimately resulted in a much cleaner and much better signal processing platform, all at a very minimal cost increase. Next, we decided to take the Revision 2 designs for the VPWMC and not only prepare them for in-field beta testing, but eliminate as many issues as possible to allow the device to be produced following the conclusion of this project. This included changes to the design of key components of the board. During alpha testing, it was noticed that the output signals were inconsistent over ambient temperature changes, so an external crystal was added to stabilize the clock better than the internal oscillator. Finally, our largest stretch goal for this project since the beginning of the fall semester was to integrate near-field communication, also known as NFC, into the design of the device. Similar to Apple Pay, this technology allows wireless and unpowered communication between the device and an external interface, such as an iPhone or RFID transponder. By implementing and utilizing this technology on the device, Takeo can perform operations from simple interfacing to wireless firmware updates to the device, all without any physical connections to the board. Doing this could save Takeo time and money, as some field maintenance can be performed with a simple iOS or Android app without spending money on a technician. Team Takeo is proud to announce that we've achieved this goal, having designed the printed circuit board, already with very limited space, to include an onboard NFC antenna, and having written firmware which allows the VPWMC to handshake with external devices. This provides Takeo with the potential to use this technology not only on this project, but also on any future project. In order to truly integrate Takeo Bus Lite into our system, comprehensive changes had to be made to the existing Takeo Bus Lite GUI. We decided to take these changes into our own hands. These changes have been made in an effort to make the Takeo Bus Lite GUI more universally applicable across the Takeo line of devices. We also decided to handle as much of the testing of the device as we could. This included the production of a demonstration test fixture for the device in order to test the effectiveness of this device against a real-world system. This test fixture utilizes the target Takeo ECM circulator pump, as well as numerous sensors to test the overall functionality. To be perfectly clear, this means that not only did we complete our anticipated best outcome in the fall, but what's more, we have in fact also completed our extended best outcome. You may be thinking to yourself, this project seems pretty easy. But the reality is that our project wasn't easy. It was just different. Our project wasn't just a design phase, but rather the whole engineering design process. The project was given to us as a concept with functional specifications. These were the governing rules of the project, and they were relatively simple. Take a 0 to 10 volt DC signal and convert it to PWM, while simultaneously taking a PWM feedback signal and converting it to a 0 to 10 volt analog signal. The device had to accept either a 12 volt DC power adapter or a 24 volt AC power input as the device power source. It also had to fit within an existing Takeo enclosure, and, perhaps most importantly, it had to be cost optimized. The signal specifications are pretty straightforward, but the enclosure was very small, and the cost optimization severely limited the options for the processing of the device. But being engineers, we took these specifications and moved into the proof of concept and prototyping phase. Here, we worked out the specifics of how to get 10 volts out of a 5 volt microprocessor, and even debated which low-pass filter designs to use based on the cost of the specific op-amps and the number of resistors required. After the initial design phase was complete, we sent out to have the boards manufactured, and when we got them back, we assembled and tested them. Immediately, a few issues were noted, but overall, the device worked. It was during this alpha testing that we created a list of needs, both for the future hardware as well as the future firmware revisions. These revisions were made, and an engineering build was sent out for full, small-scale manufacturing. This meant that the boards were manufactured and shipped to an assembly house, who then went through and assembled the boards. During this process, the boards went through a design for manufacturing process, where decisions had to be made to make sure that the boards could be manufactured in an efficient and inexpensive manner. This process required close contact between us and the manufacturer. After the boards were built, they were shipped to us for beta testing. These boards have gone into beta testing to determine if any final changes are needed before full production begins. While we do not have sufficient time to complete the full beta testing, we've moved forward to get quotes for medium and large run production, and we're happy to report that to date, the engineering build boards in beta testing have performed flawlessly. As such, it is fair to say that we have delivered a production-ready product. In the end, what does this mean to Takeo? This means that we've delivered a device that allows them to realize the $300,000 to $400,000 increase in annual revenue by entering a new segment of the market. But we've also delivered a device which is capable of a generic conversion that can be used for any future product as a means to allow interfacing between the industry standard analog control scheme and the commonly implemented PWM control scheme. What's more, with our stretch goals, we have incorporated a number of new technologies and firmware concepts that Takeo can now take and put into any of their future products. We on Team Takeo were extremely fortunate to be given a unique project that allowed us to design a product from start to finish, which meant stepping through all the parts of the engineering design process. We're extremely proud of the work we've done and humbled by the success we've had. But of course, it's important to remember that we couldn't have done it alone. So I'd like to take a moment to thank everyone who's helped us along the way. Thanks.